Thanks all for coming. Hope you enjoyed the talk today. If you're on this call, chances are it's because you have reached a certain conclusion, and that conclusion is that name matching is hard. And on the surface, this may sound a little silly when you say it out loud. If you have two names, are these the same? Yes or no? That's a pretty easy task. Even a 5-year-old can do that. But as in all things, the devil is in the details. And the details that exist in name matching is what make it a rather complicated area of text analytics. And if you think about that process, matching names is hard, then determining things like what name matching system is better, or does this name matching fit what I need it to do, really isn't any easier. So the purpose of today's talk is to really show you at a high level how a systematic approach to name matching evaluation will not just help you compare different name matching tools, but also maximize your investment in that tool once you choose it to be part of your tech stack. So a common urge with technology, in particular text analytics, is to dive right into the data and try to create a solution. As a solutions engineer myself, I fall into this trap all the time. So it's important to really pause for a moment and really think about the intended use case, because it really is a critical step. An anti-money laundering solution has different needs than a border security application. And while the results from any name matching system really should be deterministic, what those results say and how they are interpreted might vary depending on the needs of your business or mission. So the context then becomes very important when assessing the results from an evaluation process. You can't just simply look at a chart or a graph and make a decision. The context matters, and that context is going to be driven by your use case. So we're here to talk about doing evaluations, and there's lots of ways to do an evaluation. I often find identifying things that you know won't work and removing them from the process in order to filter down on the possibilities that do work is a good place to start. So imagine for a moment that we give a group of individuals a task to describe or identify a particular object or thing. But the catch is that those people are blindfolded. Now, depending on what part of the object that they're focusing on, the descriptions could be wildly different from each other. And in cases with name matching, different approaches will give you an entirely different picture. Glancing over a set of scores, cherry picking good or bad results, or looking at a specific pattern really won't give you the answers you're looking for with your name matching. Now, these approaches typically lead to poor evaluations and an incorrect understanding of what that name matching tool's real capabilities are. And even worse yet, buying a name matching tool that might not really help you at all. So what does the right way look like? The best way to evaluate name matching software is to have a formal defined process that generates quantifiable metrics that you can then use to compare against other experiments. Additionally, you want this process to be repeatable. So two things really make this work. First is you have to have quality test data, and the second is you have to have a standardized evaluation methods. So is this a time-consuming process? Yes. Is this going to be more expensive? Potentially upfront, but in the long term, you definitely will save time and money. It's a lot like building a foundation of a house. You don't really want to cut corners. Investing in this approach not only delivers quantifiable and trustworthy results that answers your questions now, but it lays the groundwork to maximize your investment down the road. So now let's get into this data. What makes good test data? In almost every case, real-world data trumps synthetic or randomly created data. Synthetic data is often perfectly random and lacks the dirtiness or noise that only exists in the real world. I have evaluated randomly generated data in the past, and the results often behave like a step function where results are grouped into bins. And what you're really looking for is something that is more evenly distributed on some kind of curve. So you might be thinking, okay, no fake data, no problem. I'll just use any publicly available real data set. This would likely reduce costs and time, but your evaluations should be on your data, not someone else's. Without a doubt, there are going to be several Peter Harding or Karen Lynn names that appear all over the world, but how that name is treated and stored in each one of those systems is going to be a little unique. Some systems might take a character and convert it to something else in order to save space. Or how about a system and how it treats missing name fields? Is it really empty, or is it going to replace it and put in a literal text value of null in its spot? These scenarios sounds pretty crazy, but I assure you, I have come across these in real life. And I'm sure the folks on the call have experienced similar kind of crazy data behavior in their own environments. So then getting back to what makes good test data, an additional criteria is that it should be representative of real world problems that you currently face. In several instances, I've seen test data that consist of thousands of rows of name pairs, which gives the impression of a good testing plan. But in reality, it was the same pattern applied over and over and over again. It didn't come close to representing the challenges that the customer talked about in the early phases of the evaluation process. So now we have acceptance criteria for our data set. The first criteria is that it's going to be real and our own. And the second is that it's going to contain representation that matches the problems that we're looking to solve. But what does it mean for data to even be representative in the first place? I'm going to look at a couple common mistakes that I see folks fall into when they're doing this in the field. The first of which is something that I just mentioned. Creating synthetic or derived data with limited variation and then applying it over and over and over again. As the little table on the right here identifies, let's say we start with the name Peter Jack Harding. Now we can create a rule and apply it to a script and generate, and that rule could say, given the name parts, combine them in different ways, and do this for every name that I see in my test set. And it'll do it explicitly. But again, this really isn't testing anything else that you would want to really evaluate. A second scenario is focusing on names that the current solution can't handle. And this comes about when folks are looking to maybe replace a system because it's failing on a certain particular problem. So the instinct is to really only test that. But what you really need to go back and include are all the things that your current system does do handle well, because it's about having equal representation of all the problems, not just your current ones. And then the third one is testing scenarios that aren't in your real world data set. You might be interested in knowing how well a tool will parse a name. Given this example here, I have a bunch of gibberish, the name Peter, followed by a bunch of gibberish. Now, if this type of phenomenon occurs in your real world data sets, then by all means include it in your evaluation set. However, if it doesn't, and it can't because of maybe some business or application logic, then this test becomes more of a gotcha. And it sort of takes away the point of the overall evaluation and its potential. And then finally, testing fields that do not appear in your real world data set. This might come up when you're, say, looking at additional fields supporting some sort of matching system, where you might consider date of birth as a core requirement. But because maybe on your application, date of birth is an optional field, and the frequency that it's actually entered is 20% or less, it really shouldn't be the focus of the evaluation. It should be a part, but it shouldn't be the deciding factor of your overall evaluation. And the point here is I'm trying to make is that you really don't want blind spots in your data. Blind spots lead to evaluations that aren't going to tell you the whole story. So the goal when creating representative test data is to have a wide view of the problem as possible. And that's the main difference between this slide and the previous one. We really want data sets that are representative and balanced across all your patterns that you currently see. So then the next obvious question is, how do we go about creating one? My preference is to start by manually creating a list of name pairs after studying and identifying all the patterns that I'm looking to see the name matching system handle. Now, this is going to take some time, and if there's software engineers on the call, I could feel their eyes roll a little bit, because any software engineer would rather build something than actually do the task itself. But I like this process because, again, you can introduce different variations to all the patterns you're looking to create and apply them differently across an entire data set, rather than just having a program which is going to exactly apply the same pattern to every data. So it really gives you a chance to introduce some noise and some dirtiness that is unique to each pattern. So now that we've identified all the different name variations and we've created our test data, the final step is to label that data. Now, this takes our data and turns it into gold or truth data. And all you really need to do here is to decide which name pairs are a match and which name pairs are a non-match. So there's 2 points I want to make on this. The first is labeled data is the only way to get quantifiable results. The second, having non-matches or negative cases is just as important as having matches. In this table, there's an example about halfway down, Karen Lynn and Carolyn. And a human would evaluate this as likely a non-match. You need to consider these non-matches to make sure your matching tool isn't generating high scores against names that shouldn't be a match. So you have to include these. So that brings us to the most obvious and most often asked question: how much data do I need in my test set? As we have learned by now, testing 1 or 2 patterns thousands of times doesn't really test you anything than doing it hundreds of times. The goal here is to have an equal amount of distribution among all the patterns you've identified, as well as the matching and non-examples of each. This will help give you all the information you need to determine how well the system works. Again, it's about quality, not quantity. The final thing to remember with your data is that it's always going to change. Name matching requirements change, patterns emerge, and your test data is going to have to evolve as that changes as well. So when it comes to your test data, there are 3 core takeaways. 1, use your own data and that it's real. Make sure that it's representative of the problems that you currently face. And make sure you really put the time and care into generating those variations and labeling it, because having high quality test data makes your evaluations worth it. And with that, I'm going to turn it over to Karen, and she's going to talk to you about how to run a proper evaluation with this test data.
Thanks, Peter. So once we've identified and labeled our test data, we want to use it to perform an evaluation. And how are we going to do that? We've discussed some of the wrong ways to do it. Cherry picking names that one system does poorly on, or looking at only a few kinds of name variations. As with the blindfolded people all touching different parts of an elephant, these don't give you a clear picture of how your tool will perform on the full range of your data. And eyeballing results to see if they look good or look bad, which we've also seen people do, is not quantifiable. In this section, we'll define a rigorous and repeatable method that allows you to objectively compare one tool against another. So the way we're going to do this is to use precision and recall metrics, which I'll define in just a moment. These give us numerical scores to characterize the accuracy of a system. We can then compare these scores across different tools and use them to make a decision based on your unique business needs. So let's dive into the definitions. Precision tells you what % of the matches are correct. The higher the precision, the fewer incorrect matches, which are also called false positives. Recall, on the other hand, tells you what % of the actual matches your system found. The higher the recall, the fewer missed matches, which are called false negatives. Now, there's always a trade-off between precision and recall, and the accuracy of a system is often considered in terms of its F-score, or F1 score, which is the harmonic mean of precision and recall. In order to better visualize these concepts, let's work through a concrete example, a system that is intended to identify pictures of cats. Now let's say that given these 7 photos, our system identified the 3 on the right as cats. What are the precision and recall of the system as measured on this small test data? So of the 3 animals that were chosen by the system, 2 were correctly identified as cats, and these are the true positives. 1 was incorrectly identified as a cat because it's actually a dog, and that's a false positive. So the precision, being the ratio of correct matches to all matches, is thus 2/3. Now the system also failed to identify 3 cats, and these are the false negatives. So that means that of the 5 cats in our test data, we only found 2. Therefore, the recall is 2/5. And finally, we compute the F1 score as the harmonic mean of precision and recall and find that it's 0.5 or 50%. So what kind of accuracy do you need? Let's go back to the use cases that Peter described earlier. In some cases, you might want higher precision, such as in a compliance process that you're trying to automate, or in the case of Amazon Alexa interpreting a voice command. We don't want false positives, and we really just want to show the top result or top results. However, for something like border security, we really don't want any false negatives, missing someone who should be flagged. So we'd aim for higher recall, showing everyone who might be a match. Again, it all depends on your business objectives. Now, in the cats and dogs example, we only had a binary classifier. Either something was a cat or it wasn't. But some name matching systems return a numerical score, which allows us to choose a threshold that emphasizes precision or recall according to our needs. In this example, I've considered the match scores of my name against a bunch of other names, some of which I consider valid versions of my name and some of which are not. You can see that if I choose a threshold of 0.8, I have no false positives, but I have 1 false negative. So my precision is perfect at 1.0 and my recall is 0.8. Now, if I really don't want to miss that Karen Lynn down there, that false negative, I could lower my threshold to 0.75. Then I'd pick up all the versions of my name for a recall of 1.0, but I'd have one false positive, this Kara Lynn, giving me a precision of 0.83. So you can see how you might use the threshold to configure a system to best serve your use case. Here's a graphical description or representation of what I just described. As we raise our threshold, precision gets higher and recall gets lower, and vice versa. If we care about both equally, we'll consider the F1 score and look for a peak in that graph. So the process for comparing name matching tools is first to identify and label a representative set of test data, and then use that data to evaluate the accuracy of your current system. Using the same method, you can then evaluate other tools and make a decision based on your business needs as to whether the other solutions are better enough to justify a change. So let's sum up what we've learned and list a few other considerations. In order to perform an effective comparison of name matching technology, you'll need to answer the following. Number 1, figure out what kind of accuracy you care about most. Is it precision or is it recall? Number 2, for your business, what constitutes a match? This is going to inform your test data set, which again needs to be representative of the data specific to your use case. Number 3, can you use match scores? As we discussed earlier, some systems return a simple yes, no, whereas others will provide a score that you can threshold on. Number 4, do matches need to be explainable? In some cases, it's necessary to know why something came back in a search result or why a given pair of names did or did not match. And finally, number 5, how customizable does the technology need to be? Do you have control over the scores that are returned? And if the mix of precision versus recall isn't right, can you change it?